Hi. I'd like to go over today's lesson. And this is the third lesson in Unit 3. And today we are multiplying unit fractions. So we're building on the work from the last 2 days. Just as a quick review here, a unit fraction is a fraction where the numerator is 1. So all unit fractions will have 1 as a numerator. And what this basically means is, and if we remember from Unit 2, this idea of fractions being division, we'll see that 1/2 is equal to 1 divided by 2. And what that looks like visually is we have one unit here, and we're going to divide this unit into 2 pieces. And so this is where we get this 1/2 understanding from. And students have been working for the last several weeks partitioning whole units into fractional amounts. So the first task that students were asked to do at the beginning of class today was to consider this model here. And we see that this model is 1 unit. And then there's a portion or area of this unit that is shaded in. And students needed to determine what size or what is the value of this area in comparison to the whole. And they were asked to determine an estimate that was too low, about right, or too high. And some students had multiple responses for each of these, which was completely fine. But what I liked about this activity was it really made students confront their current understanding of fractions as a value or as a number. So for instance, some students believed a fraction such as 1/15 would be too high of an estimate for this area here because of their belief that the denominator's value determines whether or not the actual size of the fraction is going to be smaller or larger. And while the size of the denominator is absolutely key to understanding the size of a fraction, many students assume that the larger the denominator, the larger the fraction. And that comes from years of working only with whole numbers. But once we start talking about numbers that are less than 1 or numbers that are a part of a whole, the rules kind of change. And that brings me to another point that students are very keen on remembering rules. And rules can be a very efficient way to think about math, but only after a conceptual understanding has been reached. So going back to this idea that fractions are division problems, then it becomes more clear to students, especially once we've drawn diagrams, that 1/15 is referring to a whole that's been partitioned into 15 equal areas. And 1/3 would be one whole partitioned into 3 equal areas. And so this idea that 1/15 would be too high of an estimate is actually informed by misunderstanding what the value of this fraction would be in comparison to an actual larger fraction like 1/3. And so many students have been taught that the bigger the denominator, the smaller the fraction. And while that's true, they often struggle to remember that rule in all situations. But if they go back to what a fraction is actually referring to, that we're dividing some quantity into equal groups, then that helps them to remember why that rule works. So after discussing some fraction concepts with students, most students chose two low fraction estimates for this area to be some fractions such as 1/15th or 1/20th, or even some students who kind of had a sense of humor about this activity would say, maybe 1/100th or 1/1000th or something like that. And for too high, many students listed fractions like 1/2 or like 1/3, 1/4. One student even suggested 2/5. And the about right, and this was really neat because so many students were so sure that 1/8 was the about right fraction for this. And when students were asked to show the class their thinking, what they did is they thought, well, going across the top here, or the length of this side appears to be divided into two sections. And so they thought, okay, well, this side length has been divided into two, so we can think of this side as a half of the whole. And then they thought, well, how many of these areas represented here does it appear that the half has been divided into? And a lot of students thought, well, I think it would be about 4. And once they did that, they realized, well, this is one piece out of 8 equal-sized pieces it would take to create the whole. And so that was really exciting. Now, other students thought 1/10 may have been an appropriate about right estimate. And they used similar reasoning. And but in both cases, they were using their understanding of fractions, particularly as division, to inform them of this estimate here, determining what this value would be. So that was really, really cool. Now, the next activity, students work together to write multiplication expressions for each of these diagrams. And so that was the main focus yesterday, was looking at a diagram and determining what multiplication expression would match that diagram. And so to help us understand what's going on here, we talked about the area of a rectangle. And in the last unit, we found the area of rectangles that had fractional side lengths. And so they are comfortable with understanding that area is equal to the length and the width being multiplied together. And so, for instance, looking at a diagram such as this, when they looked across one side of this rectangle, they noticed that this whole has been partitioned into 4 equal groups or areas. And so they thought of the length being a fourth. And then going down the adjacent side of this rectangle, they noticed the whole rectangle being divided into 3 equal pieces, and identified this width as 1/3, and then multiplying these factors together, they determined that the area of one of these sections here would be 1/12 of the whole. And so once that connection was made, students just, they started rattling off these multiplication expressions very quickly because it just clicked for them. So looking at the first diagram here labeled A, going across this side here, we see it's been divided into fourths. So this side length could be thought of as a fourth. And then going down the adjacent side length, we see that the fourths have been divided into two. So we have half of a fourth represented right here. And so students multiplied 1/2 by 1/4 to get the product of 1/8, which is the area of this shaded region right here. So this number sentence here, this is the multiplication expression that the activity was prompting them to determine. So looking at B, going across the top again, we notice again that it's been partitioned into fourths. But this time going down the adjacent side, we see that it's been divided into thirds. And so when we multiply a third by a fourth, we end up with a product of 1/12, which is the area of this shaded piece. Now going down to C, I'm going to write my expression down here so it doesn't get too busy up top. Again, we see that going across the top or bottom here on this side, we have one whole partitioned into fourths. And then going up the adjacent side here, we see that the whole has also been partitioned into fourths. And so the multiplication expression here would be a fourth multiplied by a fourth. And that gives us an area of 1/16. And lastly, the multiplication expression for D, we have one side up here partitioned into fourths, and then the adjacent side is partitioned into fifths. And so 1/4 multiplied by 1/5 gives us a value of 1/20, which is the area of this shaded piece here. Now, once this was determined, the really interesting part came into play, because then students were prompted to see a pattern in the multiplication expressions. And we rewrote these expressions on the board, and we wrote them down one on top of the other to try to make the pattern easier to recognize. And one of the very first things that students noticed was the fact that all of the fractions in each of these expressions are unit fractions. Another thing students noticed was the denominator in each product appeared to be increasing by 4. But what was probably the most interesting part, and I should have flip-flopped these here, was that each expression had 1/4 as a factor. And the only thing that was changing was the other factor. And so going back to the conversations we had at the beginning of the class, we wanted to know, okay, the other factor is changing, but is it getting larger or is it getting smaller? And then also looking at our products, we wondered the same thing. Are our products getting larger or are they getting smaller? We realized that, well, the other factor in each expression is getting smaller. And that is making the product getting smaller. And so this is a little bit of a foreshadowing of the idea of multiplication as scaling. So understanding that multiplying a whole number by, or even a fraction, by a factor less than 1 will result in a product that is smaller than the other factor. And vice versa, when we multiply a factor, whether it's a whole number or a fraction, by a factor that's larger than 1, we expect to see a product larger than 1. So this was really interesting. But the best part of this activity was once they identified that pattern, then they were asked, if the pattern continues, draw what you think the next diagram will look like, and then be prepared to explain your thinking. Well, students thought, okay, well, for each diagram, one of the factors was 1/4. So we're going to assume that one of the factors for this diagram is 1/4. And then they noticed when they were looking at how the other factor changed from each diagram, they noticed that the factor was getting smaller, but that the denominator in each of these factors was going down from 2 to 1, or from 2 to 3, to 3 to 4, to 4 to 5. So it was going down by 1. And so they assumed that, or predicted, that the other factor would be 1/6. And that was really neat. And a lot of students took rulers out and made very precise divisions in this unit right here. And it was very cool to see students taking so much pride in their work. And so they partitioned, many of them partitioned the fourths going across this side here, and then came across on the other side and partitioned the fourths into sixths. And I apologize, this is not very precise. And then shaded in one of those areas and determined that the value of that area would be 1/24. So that was really, really cool. Lastly, students were asked to work on this sheet, and then finally this cool down as a checkpoint for me to see where their current understanding lies with this topic. So looking at this sheet here, students were asked to first write a multiplication expression for this diagram here. And many students start by identifying the product or the area of the shaded piece. And so this is 1 out of 8 equal pieces, meaning the product is 1/8. And then they saw going across here that we have a whole being partitioned into 2 equal pieces. So 1/2 is one of the factors. And then going down the adjacent side, we see that the whole has been partitioned into 4 equal pieces, meaning that the other factor is a fourth. Now, the next task on this page was to explain how this diagram, represents the equation 1/5 multiplied by 1/3, which equals 1/15. And students, again, often started with explaining that the product 1/15 is correct because this is one equally sized piece out of 15. And then many students identified each side length. So they would say something like, well, going down here, it's divided into 5 equal pieces, or this side represents 1/5, or they would draw or write, a fraction 1/3, so like this, and draw an arrow here. So they use different ways, words, they use numbers labeled. They use different ways to justify 1/5 multiplied by 1/3 equaling 1/15 being represented correctly in this diagram. Lastly on this page, and I'll zoom in here a little bit. Hopefully this is a bit easier to see. They needed simply to find the value of these two expressions. And they could use a diagram, but many students have picked up on this generalization or this rule that to evaluate a fraction multiplication problem, one only needs to multiply both numerators and then multiply both denominators to find the numerator and denominator of the product. And this rule is great, but students have come to realize this rule through their own understanding using models and pictures. And so coming up with this rule on their own is much more meaningful than simply telling them what the rule is at the beginning of the unit. Some students will remember that multiply the numerator by numerator and put it over the denominator times the denominator. But many students won't, and will forget this rule once the unit's over. And especially will forget this rule before the beginning of 6th grade, where these concepts are reviewed again. So understanding where this rule comes from by first starting with more concrete representations of the fraction multiplication is really critical. So going down here, we have 1/4 multiplied by 1/6, and that gives you 1/24, which many students already knew from the earlier problem. So students were asked to do a total of 3 things here. First, to identify the multiplication problem represented, and that would be 1/3 multiplied by 1/3, which equals 1/9. And that comes from the top and bottom sides of this whole being partitioned into 3 equal pieces or thirds, and then the adjacent sides also representing 1/3. And again, many students recognize this is 1 equal piece out of 9 total that it would take to make the whole. And so oftentimes the product is determined before the factors are determined. And then they check to see if the factors agree with the product. And lastly, these 2 questions are just like the 2 we just went over. It's simply a computation problem where they're multiplying both fractions, and they are prompted to use a diagram if it's something that would help them. But again, many students simply use the rule to quickly and efficiently determine the products. So that is lesson 3 in a nutshell. Students have been coming along really great with this fraction multiplication idea. It's really encouraging. One of the things that I've been challenging students with is drawing a diagram or presenting them with an already drawn diagram, and then asking them to determine the expression as well as the product. So this is something that they can do at home to practice, is to kind of create their own fraction multiplication problem. And so they can draw a rectangle to represent the whole, and then partition it on one side however they would like. So in this case, we could call the length of this side as representing a fifth, especially if we colored one of these in here. So this would represent a fifth. And then we could partition this fifth any way we'd like. We could partition this fifth into 5 equal pieces. And so that would correspond to a width of 1/5. And this would be the same thing as finding 1/5 of the 1/5. And students could understand or extend these partitions and recognize that the area here would be equal to 1 out of 25 equal pieces. And I've even had some students ask if they can draw pictures or diagrams to challenge their classmates with. So this is kind of a fun way to practice the multiplication concept with fractions. As always, please send me a message on Remind or contact me through my email address. If you have any questions, I will try my best to get back with you within a 24-hour period, but I try to get back as soon as I can. And I hope this video helped.